very useful because all of them have been optimized for some different reason. So some of them are good for low frequency bands because the noise there tends to be impulsive from lightning and the thunder somewhere in the world, and other ones are better for the higher frequency bands. Some of them have very strong error correction, others don't. But this is just a one section of looking at Thor, and so this is they're waterfalls that you're looking at. So across the top is frequency, and then down the page is time. And you can see the first thing that happens when you send, say, Thor 4 up in the bottom left. There's a rising series of tones that go up. And that actually is used to synchronize the transmitter and the receiving station. So you don't have to have an external time standard to be able to exchange these signals. And then down in the operating parameters, you can see the required bandwidth, the transfer of speed, and this is pretty typical of each of these modes. They have many different sub-modes which trade off bandwidth against symbol rate on these things. Anyway, what David, Whiskey One Hotel Kilo Charlie, is the guy who looks after FL Digi. And as I say, he basically runs, his program runs on Windows. And he put me in touch with an Australian, John, VK2 Echo Tango Alpha, because John had moved all of the modes from FL Digi into Android. Okay, John created this Android app called Radio Message, and it has an interesting history, actually. It was originally put together for traveling across the Western Australian desert, where you can easily generate dust clouds that are several kilometers in diameter. And you don't know where your companions are. They're lost somewhere in the dust. And so radio message was put together to use a phone as a terminal with a 2-meter radio to be able to send positions, send photographs, just coordinate this bunch of lost people going across the desert. And he had, it's open source, as FL Digi is, and it uses all of the FL Digi code for all the different modems. John was he was very interested in the CaveRadio project, and he was just most helpful to us. He understood, because of this background of working with people in the outback, he understood immediately what the cavers needed and in terms of information and how they wanted to transfer it. And so he put together this project, and there were 3 of us working directly on the project. And it was the first time I had done this. I'd never met John or had talked to him or know what he looks like or anything else. And we were there swapping messages, sort of someone would put up a note saying, I need to get this particular measurement to understand this. And within an hour, the measurement would have been made and sent back. And it was just great. It was a marvelous experience, actually, to work through and do that. This is a picture of in the center is the QDXM. At the bottom is the phone that is being used as the terminal, and the top is a voltage regulator for it. So that's what's basically replacing a laptop computer and a single sideband radio and the audio interface that's you need when you set up to do digital work in a shack. And then on the right, this is basically what the screen looks like. It's a fairly early version of radio message. So it still has, instead of transmit, it still has things like SMS. send position, which you can't do because you don't have GPS and stuff like that. But you can see the indenting of the messages that you're sending and receiving, the timing that's going on, the information about who it's being sent to and not sent to, and stuff like this. Yeah, and then this is just a couple of pictures of the packaged unit. The whole thing fits into, all except the antenna, fits into a very small Pelican case, and yeah, that's it in action, 100 grand. And I think the last one is just the acknowledgement of the just a lot of the people who've participated in this. There's myself doing the modifications to the radio, and John creating the radio message app. Brian Pease, who is in Vermont, who has just been, he was an electrical engineer by profession, and just had a very useful guy to have in. Ken, who was invaluable in the testing and just the organizational support and getting everyone where they needed to be when they needed to be, and ideas on it. Stuart, who did the cave packaging and the user training, which paid off in spades when the rescue happened at Canmore last week. Leve and Evan, who I have never met, but who are in Victoria on Vancouver Island. And it turned out there were a number of subtleties about supplying power to a phone that was at the same time controlling a different client. I hadn't realized that there were some issues around getting the phone to recognizing whether it was in charge or not in charge. And Christian Stenner, who did a lot of, he's involved very much with the cave rescue, and he did a lot of the obtaining funding, and also just the cavers who have shown a lot of interest and just help with the field trials and just been great. So the whole project I've really enjoyed it and really appreciate all the help and support that I've got over the times. I think that's it, Jerry.
Questions for Ian.
So, Ian, what's the go forward plan to make it more universally available to others?
Well, the key holdup at the moment has been the firmware from Hans. On me, he must be just an amazingly busy person there, and as he's developed the firmware. So, for instance, for the QMX, when you go into that, you're given an option as to whether you want to what zone you want to use the band definitions for, or do you want to be able to, you have the Japanese bands, and then it actually gives in those ones it gives you the option to be able to operate outside the actual ham bands if you make that decision. And I mentioned earlier on the UK, they have an agreement with their regulators there that their cave radios operate at 87 kilohertz. So we're just not going to be able to do anything with that at all. I mean, I've actually done the design work and actually made some low pass filters for working for 87 kilohertz and stuff like that. But the firmware won't allow me to operate at that. It won't allow the radio to operate at that frequency. So that's certainly going to be one of the problems. I mean, these other we're fortunate here in Alberta and North America in general. Actually, the cavers have a lot of amateur radio people associated with it, and so we can just about every time we want to do anything, we can find a ham radio person who's prepared to basically say, "Okay, I'm." The key operator sort of thing on it, but that's not the case in Europe. And so they've been reluctant to want to move into the ham bands. There was a question down below. Sorry, go ahead.
Oh, I've got one question. I'm the one I put it in the text there, so this is just going to be a repeat. But is antenna polarization important on this, or because you're in the near field, it really doesn't matter?
Interesting question. If you'd asked me before I did this work, the answer is that polarization is very important, actually. But it turns out that these radios are so sensitive that if you're only sort of 100 meters or so apart, you basically, the polarization doesn't matter because there's enough signal to get through, if that makes sense.
Uh,
So it doesn't matter
totally.
if you lose 20 dB because of cross polarization.
Okay.
And then when you go beyond 100 meters, you start running into the secondary fields that you get induced in the ground. And so, in fact, you lose the sharp nulls that you use for radiolocation. That's why the radiolocation has gone to such low frequencies, 3.5 kilohertz, right?
Okay.
So at 137, you end up with this next period where the polarization doesn't matter, and it's only when you start getting into the sort of 400 and 500 meter distances and further that the polarization starts to be important.
Right. Okay. I've
So,
got some antenna wire I want to get to you just for free to test out, but that's a different thing because that dives into like my business. But I'm not sure if you're aware, there's a guy out there, he has a thing called DigiPi, and it's a Raspberry Pi, and it has FLDigi and a whole bunch of other digital modes in it. And I
okay.
realize that you have your Android directly connected to the radio, which is good.
Mhm.
But if you use DigiPi, it would allow multiple users to log into the Raspberry Pi as a user and be able to use it out. So you'd be able to have one transmitter and multiple users on that. So I think that's one thing that you should maybe investigate is I think it's called digipie.org, and I'd recommend you look at that if you're not
Sure.
already
Okay.
aware.
I'll certainly make a note of that. One of the things that
Hmm.
I'm discovering is that, I was doing the radio stuff,
Hmm.
um, and I very quickly discovered that when started moving into what phones did do and didn't do, that
Hmm.
my knowledge was almost zero. And people were just sort of automatically assuming that they could do various things because of
Right.
their knowledge of the phone. So I will look at
Well, we're
DigiPi and
everybody's limited by what they've been exposed to. So hopefully
yeah,
that'll
yep,
I don't know if that's going to be a solution for you, but it's something that I think warrants you looking into.
sure,
That's all I got.
okay.
Thank you.
Okay, I have a question here. This is Rob. Just wondering, there's lots of excitement in the ham community about mesh plastic, and those units can be make small and rugged, right? So just wondering, do you see them as sort of, are you leaving them as a breadcrumbs going
Um,
in
yeah,
and communicating out?
I'm certainly aware of the Meshtastic stuff, and that book on CaveRadio from the RSGB that I mentioned certainly has a chapter on exactly that technology. And you'll find lots of articles on the whole mesh systems in the Craig Journal.
Mm-hmm.
The issue is that caves they vary obviously from big walking passage and stuff, and then they'll close right down to something that's only a foot wide and is sinuous. And the range of the mesh tastic stuff might go down to perhaps literally 3 or 4 feet
Right.
because of the high frequencies. So there have been some people experimenting with mixed systems in which you have a receiver and then you run a wire for maybe 100 or 200 feet to get you through the narrow sections or the crawls, and then you go back to the radio mesh, if I can put it that
Mm-hmm.
way. So you end up with this sort of hybrid system that's partly radio and partly wire.
Okay, thanks.
I have a question.
Go ahead, Marshall.
Uh, what can people in mining and earthquake rescue learn from this, and what can this work learn from mining rescue and earthquake rescue?
Oh, okay. Going back to the to mining, first of all, um, the mining companies have looked at this, and there have actually been some commercial development of it back mainly in the voice days. Mines have tended to go to leaky feeder systems, for example, where you put the radio signal down a coax that has a poor shield on it, a deliberately poor shield, so the RF leaks out of the coax, and then you can just communicate using an HT radio. The mines tend to have a lot of services running through them, so they're not so much interested from through the earth stuff as they are a long passage communication. As far as earthquake stuff is concerned, I mean the problem there is that you need a radio or a device at both ends to be able to communicate through. So I think, you know, if you're trying to explore a collapsed building or something like that, the issue is not one of distance through solid rock, which you have with the caves. It's more you know, it's shorter distances, and the medium is broken up and has a lot of airspace in it and stuff. So I don't, you know, I don't see an immediate application for it.
Ian,
Mhm.
it's Jerry.
Yeah, hi Jerry.
Hi. I just have a quick question about the antenna.
Okay.
Is that a resonant antenna?
Yes, it is.
Okay. And how do you?
The it's a loop of and what we've been using normally is just a piece of power cable. So it'll be sort of 16 gauge or 14 gauge 3 turns, and the older traditional method was to resonate it with capacitors and then to use a small pot core transformer to be able to transform the impedance down to 50 ohms. But one of our friends, Brian Pease, that I mentioned in the acknowledgements at the end, he's worked out a way to divide the capacitance and actually hook up the antenna in as a series rather than parallel tuned loop, which is actually looking very promising. So there's probably going to be a change in technology in what is probably the oldest part of the CaveRadio technology.
Okay. The other question that goes along with that, I assume that the frame is assembled when the person gets down to where he wants to communicate.
Yes, that's correct. There's the white hub in the middle is a machined piece of Delrin, and you can take out 3 of the struts and just roll it down into to do that. And some of the bigger ones we actually have used tent frames, you know, fiberglass tent poles, so
Okay.
the thing springs out, and then you put them down. There is another type of antenna that's commonly used in the UK, and that's earth current injection. So they were having trouble with the range, and you remember the 2 ways to improve the range. You can reduce the noise, okay, to increase the signal to noise ratio, or you can increase the signal. And they were increasing the signal by they would run wires out for perhaps 10 or 20 meters on either side of the radio, and actually put skewers into the ground, and then actually inject the RF current into the ground, and that turned out to give a more powerful signal than the loop antennas. But it's not mobile, so you have it's longer to set up and not mobile once you've set it up. So there's a lot of interest in the loop antennas if you can get the adequate range with the loop antennas, because you can move around with them and you have some mobility and speed.
Thank you, Ian.
Mm-hmm.
I have a couple questions.
Yeah.
First one of I think the main breakthrough with the WSJT and the signal to noise ratio was the fact that they could hear below the noise floor, and as you were pointing out, -20 to -30 dB advantage over a single sideband. But that technology is 20 years old, whatever. How does that compare to FL Digi and the mode that you're using? Because it seems to me that the algorithms that Joe Taylor developed were really the key to that breakthrough with the signal to noise.
You're exactly right, Jerry. And in fact, Brian Pease, whose name's just come up before, he's actually actively looking at this at the moment. I mean, I mentioned that one of the decisions we had to make was which of the FL Digi modes we were going to use, and the ones we've looked at mainly have been Olivia and Thor, because we understand that they're optimized by the authors for the low frequency bands. But it's not actually turning out to be quite as simple as we thought. We've looked at Olivia 4-125, I think, is the one we've been looking at, which is probably the fastest one, but has the wider bandwidth. And then we've looked at Thor 4, and then there's one called Thor Micro. And Brian's comment was that Thor Micro made watching paint dry, it's an exciting pastime. And on these things, and also it's looking as though the Olivia is actually turning out to be faster than Thor 4, which we didn't expect. So we still have a lot to learn about it. Now, one of the nice things with the radio message is that all of these modems are built into radio message. And so it's literally a few seconds to be able to change the mode. The one of the other things, radio message also has, Ken might have to help me here. What's the mode where it listens to what's coming over and decides what mode it is and changes the modem?
Well, you can invoke the Reed-Solomon ID,
Right,
both on TX and RX. So
okay.
if you've got neophyte cavers trying to use this gear, and one of them has it set on, Thor 4, and somebody else has got their receiver on Olivia, it doesn't matter, because, the radios will immediately synchronize to the mode of the transmitting station. That's the cool thing about those RSIDs.
Okay, and you can run into problems with that because the actual modes themselves are more sensitive than the Reed-Solomon ID, and so if you're at the extreme limit of your range, you do have to make sure that you're on the right mode. But for the closer modes, you can get the automatic switching. So that way you can try the as I say, try at the time and have a look. I haven't mentioned another application that we found really useful as well on this, and it's called Spectroid, and it's just available from Google Play. And I think it was originally designed for
Yeah, sure. I might as well. We were given some funding through Search and Rescue Alberta, and indirectly, of course, from the Alberta government. There is a formal cave rescue organization in Alberta. It's a registered society, and there's one in BC as well. The two operate together under a memorandum of agreement as a common organization because caves don't respect provincial boundaries. In fact, there's a cave that literally goes under the Alberta-BC boundary down in the Crow's Nest Pass. So the Alberta/BC Cave Rescue Service, as it's known, is the owner of these radios. Because we were specifically given funding by Search and Rescue Alberta to do the development work, but also to establish, a suite of them to put in our equipment caches. So although we're still doing some final touches to the packaging, Stuart DeHaas, who I think some of you have met or know, is also a ham and an engineer. He currently had possession of them all, which was a good thing that they weren't sitting in my basement, because when the call-outs happened for this particular rescue, I got my call-out notice on an offshore island off the coast of Nova Scotia on a sea kayak expedition. So I was not there, but the radios were quickly taken out from Calgary to Canmore and deployed in the cave. So we got all kinds of stuff in cave rescue, ropes and haul system gear and helmets and, stuff.
Did you have any issues with performance, or did the radios work as planned, as hoped?
We were delighted. I hear this indirectly because I wasn't there, but they basically performed flawlessly, and we were very encouraged because during the testing phase we had a couple of hiccups. Never once with these QDXM radios or the antennas. But the interface with cell phones was tricky. Finding, some cell phones, you have to have a certain level of Android or later. And certain cell phones, even with that level of Android, had some funny quirks that did audio processing that caused problems. And we had one notable fiasco where radios that had been working perfectly just all of a sudden stopped. And we found out there was a logic bomb in radio message that as of a certain date, it just turned itself off. That's all been fixed now, but this is a typical development project. But we're pretty comfortable now that we have really high reliability. And as Ian pointed out, one of the important things to us is that these things can be thrust into the hands of somebody who's never seen one, who's a good caver. They happen to be among the first on scene at a rescue, but they're not a ham. And so we have to have a little quick reference sheet that just says, take this phone, stick this USB-C in that end, and stick this other thing in the radio, and do this in this order. And they did, and it worked. So we're delighted with that.
So Ken, I'm going to reiterate the DigiPi thing that I had mentioned earlier. It's platform agnostic, and you literally just use a web browser on your phone. It creates a Wi-Fi hotspot, and you log in. I think that might solve some of your problems. It also opens up more problems, but I really do think you guys need to look into that one.
Yeah, no, that's a good takeaway for sure. There are some things radio message is already geared up to do, but it doesn't give you many-to-one operation of one radio. You can set them up to relay. So one of them can be an unintended relay station to boost your range. And you can, if there's a Surface phone that's got the internet connection has got the card in it and all that, you can actually then relay onto regular SMS or email with the Surface unit, right? So we could relay to the Surface and then from the Surface out to, say, a doctor in Calgary. We haven't played around with that aspect a lot yet, but it is built into radio message. But it is still one-to-one, control person, one phone to one radio at this point. Yeah.
Definitely get a hold of the DigiPi guy. He's got a YouTube channel, but I'm going to send a message over to Ian. Maybe I'll look up your email as well and maybe send it to you.
Yeah, please do. Thanks.
Any issues with regulatory problems of people that are not licensed amateurs using this?
Well, not yet. Like all of the rescues, we have got, fortunately, enough hams in the cave rescue and general caving community that there's always been a situation where there's been a control operator, right? But yes, we are currently still using a ham band frequency. Historically, we were out of that with the 185. It was sort of a license-free band in the U.S. for a long, long time. There's all kinds of history tangled up in this. The other thing I guess I should point out, and I'll ask Ian to comment on it technically, we are using the magnetic portion, and these things hardly even radiate an E field. It's like, I don't know, picowatts, right, Ian? So it's you can argue that we're not radiating out a band.
Yeah, there's a lot of discussion that's gone on around this, including some people who are radio engineer professionals. And you can, we refer to the loop antennas on these things, but in fact, the efficiency of the antennas is so low that you could actually consider it to be a dummy load. The calculations that we've done on it, the most power with 5 watts going into the loop, the most power that we've been able to figure out that we would be radiating like into the far field is 40 microwatts with, into a hemisphere. So I mean, the chances of causing any interference or indeed being heard are minimal, essentially. So.
Very good. Well, any last questions, comments? All right. Well, thank you very much, Ian and Ken and everyone involved, and for the suggestions as well. There's a lot of technical or many technical aspects of this whole project that are still open-ended, and I'm sure we'll be seeing more developments and whatever. But this has been a great story and a real success one, and thanks to the foresight of people like Ian and Ken and whatever, knowing that you need communications certain times when you get in trouble. I've not been caving other than like at Carlsbad or something like that, where there's an elevator to take you back up. So I don't have any real appreciation, nor do I want, of some of the things that you run into there. But you know, to me, it's amazing what people will do. And I understand that the person who got in trouble was off the beaten path, so to speak, and they decided to go a little on their own. It was still known territory, but you know, I mean, that's, I guess, fair enough, but it's not my thing. But,
Okay. Well, thank you for the opportunity to talk, guys. I hope you found it interesting, and we'll see you around in the ham radio world.